Okay, so let us now solve 31st question from the practice sheet. The question says, in the given figure, ABCD is a square of side 14 centimeters with centers A, B, C and D. 4 circles are drawn such that each circle touch externally 2 of the remaining 3 circles. Okay, any 2 of the remaining 3 circles. Find the area of the shaded region. So let us analyze the diagram of this question. Question number 31. It says that there is a square. So we have drawn a square ABCD. Now using ABCD as a centers, we have drawn 4 circles. And how we have drawn the circles? We have drawn the circles in such a way that the circle drawn from any point, for example from point A, will touch any 2 circles, only. So if I draw a circle from point A, it will be something like this. And if I draw a circle from point B, it will be something like this. If I draw a circle from point D, it will be like this. And from point C, it will be something like this. So these are the 4 circles that I have drawn. So what is the speciality of these 4 circles is that if I see the circle drawn from A as the center, this circle is touching these 2 circles, not this circle. If I take this circle is touching these 2 circles, but not this particular circle. If I talk about this circle is touching these 2 circles, but not this circle. And we have a region in between these 4 circles, and we need to calculate the area of this region. Okay. So what it says is, you need to determine the area of this region. Now it is given that the side of this square is 14 centimeters. Side of this square is 14 centimeters. Now how to determine the area of this region? What I can see is, if ABCD is a square, it means if I take a paper of 14 by 14 dimension, and if I remove this part from this square, and if I remove this part from the square, similarly this part and then this part, I will be left with only this much part. So how should I remove this part? What should be the radius of this part? Can I calculate the radius of this part? Try this. Let us try this. How to calculate the radius of this part, this circle, or this circle, or this circle, or this circle. Are these circles symmetrical? Can I say that all the circles are of same dimension? Let us think about it. So what I am trying to say is, the 4 circles that I have drawn taking ABCD as the centers are of equal dimension. Why they are of equal dimension? Because from the figure it is very clear that all the circles, the lengths, the radius of all the circles, the size of all the circles are similar. So all the circles are of same dimension. But do I need to calculate the complete area of circle? No. My required area is only this much. What I need to do is, I need to remove this much part only from this square, and then I need to remove this part, then I need to remove this part, and then I need to remove this part. if I see this part in respect of circle, what I can see is this part is basically a sector of this circle with center B. This part is the, let us say this is region 1, this is 2, this is 3, this is 4. What I can see is region 1, 2, 3 and 4 are symmetrical. They all are symmetrical. Now can I calculate the area of region 1? Yes, very easily. How to calculate the radius of this circle? See, this complete length AB is 14 centimeters. So what is the half of 14? Half of 14 is this much length, that is 7 centimeters. So radius of circles is equal to 7 centimeters. Now we have the radius. Now what will be this angle? Since it's a square, so I will say that this angle is 90 degree. Then I will say area of shaded region is equal to area of square minus area of quadrants. Yeah, area of 4 quadrants. So if I remove the area of these 4 quadrants from the area of square, I will get this desired area. And what is the area of each quadrant? Let me write the area of each quadrant. Area of each quadrant is equals to 90 into pi times 7 square upon 360. Okay, so you need to solve this and calculate the area of one quadrant, then multiply it by 4 to get the area of 4 quadrants and subtract it from the area of square. Now I am not solving this further because we have solved a lot of questions based on the same concept. That's why you need to complete this question yourself. So this completes question number 31. Now let us move to question number 32. Question number 32 says, the given figure shows a racing track whose left and right ends are semicircular. Okay, the distance between the two inner parallel segments is 60 meters and they are each 106 meters long. If the track is 10 meter wide, find the distance around the track along its inner edge. Then second, find the area of the track. Okay, so what it says is, question number 32, it says that there is a racing track. So first let us draw a racing track. The racing track is something like this. This is the racing track. Okay, what it says is the left and right ends are semicircular. So this is one of the end, this is a semicircle, okay, and this end is also a semicircle like this. Then this end is also a semicircle. This is one semicircle, this is second semicircle. Okay, the left and right ends are semicircular. Now what it says is the distance between two inner parallel lines. What are two inner parallel lines? This is one of the inner parallel line and this is another inner parallel line. The distance between these two lines is 60 meters. So So the separation between the two lines is 60 meters. Then it says they are each 106 meters long. So each line is 106 meters long. So this distance is 106 meters. This is 106 meters. Okay. Then if the track is 10 meter wide, so width of the track is also given. The width of the track, this track is 10 meters. So 10 meter is the width. Then you need to determine the distance around the track along its inner edge. Now what does this mean? The distance around the track along its inner edge? It means I need to calculate this distance. Let me mark the distance. I need to calculate this distance. This distance, or I should say the length of inner track. Okay, the length of inner track is what is required. Then second thing you need to calculate is area of the track. So let us focus on the first question. It says the distance around the track along the inner edge. So the distance along the track around the inner edge, we can see it is divided into 4 parts. This is, let us say, A, this is, let us say, B, this is, let us say, C, and this is D. So the distance around the track along the inner edge is equal to the length of AB arc. Okay, because AB is what? It is the arc. This is AB. Plus, after AB, the BC is a line. So plus BC. Plus CD is what? CD is again an arc. So plus CD, which is an arc, plus DA. This is DA. Okay. So I need to calculate this length. Now for solving this, I need the length of AB arc. Now what should be the length of AB arc? This is a semicircle and AB is what? It is 60 meters. So this contributes 60 meter. So I should say that the AB represents the diameter of semicircular track. Now since AB represents the diameter of the semicircular track, which is 60 meter, okay, diameter is 60 meter, so the radius is equal to 30 meters. Okay, so the radius is equal to 30 meters. Now we have the radius of this, let us say this point is O, so we have the radius OA. What will be the length of this arc, this semicircular arc? We say that the length of this semicircular arc, you know what is the circumference of a circle? Circumference of a circle is 2 pi r and it is a semicircle. So what will be the length of this semicircle? The length of this semicircle will be pi into r. So in place of AB I can write pi into r, where r is 30 meters. Okay, let me repeat what I am saying is, I am saying that the AB, this part represents a semicircle. The circumference of a circle is 2 pi r. So the semicircle, the length of or the circumference of semicircle should be half of 2 pi r, that is pi into r. So this is the length of arc AB. Okay, then plus what is BC? BC is 106 meters. Now similarly, what is CD? You can see AB and CD both are similar arc. So the radius of this, so the diameter CD is also 60 meter. The radius of this track will also be, equal to 30 meter. So the length of this arc CD will have to be pi times r plus DA. DA is again 106 meters. Okay. Now this is pi r and pi r, so pi r plus pi r is 2 pi r. I can write it as 2 times pi into r is 30 plus this is 106, this is 106, so this will give you 112. So this is 60 pi plus 112 meters. Okay, so this will represent the length of track along the inner edge, or the distance of track along the inner edge. Okay, so we have calculated the first part of question number 32. Let us solve the second part. Now what the second part says is, find the area of the track. Now what will be the area of the track? Let us mark the area of the track. This will represent the area of the track. This is the area. Okay. Now, how to calculate this area? We can see that this particular area is divided into 3 different parts. What are the 3 parts? The 3 parts are like this. The first part, this part, okay, let us say this is the first part. This part is made by semicircles. Okay. The second part, that is this part, is made by rectangles, and the third part, that is this part, is also made by semicircles. If I can see the area of this region, this part, area of region 2. So the area of region 2, area of region 2, it will be equal to what? It will be equal to, if I subtract this smaller rectangle, if I subtract this smaller rectangle from the bigger rectangle, from the area of bigger rectangle, I will get this area. So what I am saying is, region of area of region 2 is equal to area of outer rectangle minus area of inner rectangle. Now what is the area of outer rectangle? For that we need to calculate the length and breadth. Okay. So if I talk about the length of the outer rectangle, the length of outer rectangle is 106 meters, and what is the breadth of the outer rectangle? This length is 60 meter. Okay, plus this length is 10 meter, plus this length is 10 meter. So the breadth of the outer rectangle will be equals to 60 plus 10 and plus 10, that is 80. So the area of outer rectangle will be 80 into 106. Now minus, what is the area of inner rectangle? The length of inner rectangle is 106 and the breadth is equals to 60 meter. So I will subtract 60 into 106. So the area of region 2 will be 20 into 106 meter square. Okay, 20 into 106 meter square. Now let us calculate the area of region 1. Area of region 1 will be equals to what? If you can see, there are 2 semicircles. This is a bigger semicircle and this is a smaller semicircle. Now what is the radius for bigger semicircle? The length of this diameter for bigger semicircle is 60 plus 10 plus 10, that is 80. So if I talk about the radius of bigger semicircle, the radius of bigger semicircle or the outer semicircle will be equal to 40. Now since it's a semicircle, so what I am going to write is, area of region 1 is area of outer semicircle minus area of inner semicircle. Okay. Now what is the area of outer semicircle? it will be equals to half of area of circle, that is pi r square upon 2. So area of outer semicircle is pi times, now what is the radius? Just now we have determined the radius, total length, the diameter is 80, so radius will be half of this, that is 40. So pi into 40 square divide by 2, because it's a semicircle, minus area of inner semicircle. Inner semicircle, the diameter is 60, the radius is 30, so it will be pi into 30 square upon 2. So area of region 1 will be equals to pi by 2 to the bracket 40 square minus 30 square and meter square. This is the area of region 1. Now what about area of region 3? Region 1 and region 3 are symmetrical. So I can say area of region 3 is equals to area of region 1. Okay, area of region 3 is equals to area of region 1. So what will be the total area of the track? Total area of the track is area of track is equal to area of region 1 plus area of region 2 plus area of region 3. Okay, the area of this region plus area of this region and plus area of this region. So this is the total area of the track. Okay, so this is the solution for question number 32. Again, it's a very interesting question, very lengthy question. It is important for a 5-mark question. Okay, so first you note this, then we will continue.